Hi, and welcome to our Mad Science series. Thanks for joining us today. My name's Haley. I'm the children's specialist at the Tewksbury Public Library. And today we're going to talk about Newton's 3 laws of motion, and we are going to work on our very own snowball launchers. So let's get started. For this experiment, you will need a lab report, a pencil, a cup with the bottom cut out, a snowball, half a balloon, so the top's cut up top here, and the bottom's tied, and some tape. To put our snowball launcher together, take the balloon and stretch it over the bottom of the cup. Like this. Might be a little hard at first. Once you've got that done, hold it in place and tape it down. All right, put one last piece of tape on the very edge here. Tape it down as much as you want. Make sure it's not going to pop off. It's an important part of the experiment. All right, once we've got that all taped into place, we're going to take our snowball, put it in here. I'm going to write down my hypothesis. So it says in the hypothesis section, write down what you think will happen when you pull back and release the balloon. So what's going to happen when we pull this back when the snowball's in there? So I think that the snowball will launch across the entire craft room. All right, step 4 says, were you right? So we've got to test it out. So take your cup, drop your snowball in there, and let's see. All right, it landed all the way over there. I was right. All right, you can keep experimenting, keep using your snowball launcher to launch some other things across the room. And once you're ready to learn why what just happened, the science behind it all, keep watching. Okay, let's get into the science. So Isaac Newton was a scientist who lived quite a long while ago, and he discovered a couple things you're probably familiar with, like gravity, but he also figured out 3 laws of motion. So we've got 1, 2, 3 of them. So the first one is that an object at rest will stay at rest and an object in motion will stay in motion until a force acts upon it. So the snowball, when we drop it in this snowball launcher, doesn't pop out. It doesn't move. It's at rest. It's going to stay at rest. When we pull the balloon back, we're creating a force to act upon it, so it launches up. Why does the snowball stop moving, right? Because we know that an object at rest stays at rest and an object in motion stays in motion until a force acts upon it. So what's acting upon the snowball to stop it from flying through the air? So we've got a couple things like air resistance and gravity that act upon the snowball as it's moving. So it starts slowing down and then it eventually stops moving until you pop it back in your snowball launcher and launch it through the air again, adding another force to act upon. So Newton's second law of motion says that force equals mass times acceleration. But what does this mean? So I'll break it down for this experiment. So mass is our snowball, and the force is what we're creating when we pull this balloon back. So if we pull it back just a little, it's not going to launch our snowball as far as if we pull it back all the way back. It's not going to move as fast, and it's going to stop moving a lot quicker. So when you replace the mass with something that's a little bit lighter, a little bit heavier, it's going to affect the acceleration. So if we put a tiny little goldfish in our snowball launcher, it's going to fly through the air. But if we put something heavier in there, like maybe the cutie that you sometimes have in your lunch, it's not going to move as far. That's all because of this equation here. Force equals mass times acceleration. And the third law of motion is that every action has an equal and opposite reaction. So in this experiment, when we pull back the balloon, we've got an equal but opposite reaction onto the ball. So pairs come in forces. We've got the balloon and the ball for the two forces in this experiment. Another example would be you sitting in a chair. So I'm sitting in a chair right now. I'm not falling through the chair because as I sit down, I'm exerting a force upon the chair, and the chair is exerting its own force upon me. So we have that equal but opposite reaction, so I'm able to sit in the chair without collapsing through. And those are our 3 laws of motion. So you can thank Sir Isaac Newton for this lesson, and we've got our fun little snowball launchers for lots more experimenting. So have fun. Remember to play around with how far back you pull this balloon and what you put in here. Do be careful. Don't point it at other people, please. It can be a little bit dangerous, but have fun. You can fill this lab report out if you'd like. I've got a section here so you can draw what happened, or you can take a picture if you'd like. And come into the Tewksbury Public Library and let us know how the experiment went. Thanks for joining me today. I hope you had tons of fun experimenting with mad science. Make sure to hit subscribe and follow us on Facebook, Instagram, and Twitter at Tewksbury LIB for more experiments. We've got another one coming out in February. Happy experimenting, and I'll see you next time. Bye!